Hello, everyone, and welcome to math class. Today we are doing 29A. All right, and we're doing more word problems. So these are going to be quite similar to our last worksheet and our last lesson. So I hope that you've gotten a little bit of practice with those kind of problems, and now we're going to apply them in a slightly different way with this worksheet. Richard is 5 times as old as David. So we're just going to take that sentence and translate from English to math. So Richard is 5 times as old as David. So we need to take David and multiply him by 5, and we would get Richard. So 5D. In 5 years, Richard will be 3 times as old as David. So in 5 years, so I would say, so Richard today is R, but Richard in 5 years would be R plus 5. So we have in 5 years, Richard, so R plus 5 will be 3 times as old as David. Richard is 5 times as old as David. So yes, so we multiply David 5 times to get Richard. And then in 5 years, Richard will be 3 times as old as David. So, but it's not just 3D, it's going to be 3D plus 5 because it's 5 years later. So it's not just 5 years for Richard, it's going to be 5 years for David as well. Okay, so we've got so how many equations do we have and how many unknowns do we have? So I have 2 unknowns and I have 2 equations, so I'm ready. So my first equation is already in the format where I can just substitute in. So I'm going to substitute 5D in for Richard. So I have 5D. Remember, I'm just rewriting this equation, but I'm subbing this in for this one. So I'm not going to write R, I'm going to write 5D plus 5 equals 3D plus 15. Okay, get all of our letters on one side, all of our numbers to the other side. I'm going to subtract 3D over here. 5D minus 3D is 2D. And subtract 5 over here. 15 minus 5 is 10. And then D equals 5. Okay, and then I can just substitute this one back in. That means Richard is, if David's 5, then Richard is 5 times 5 is 25. Okay. So pretty simple. We're just translating English to math, and then we're solving. Substitute and solve. Next year, Joanne will be 6 times Nicole's age. Okay, this sounds really similar to what we just did before. So you might want to pause. This is a great time to pause and see if you could do the next problem on your own, and then push play and see if our answers match. Next year, Joanne will be 6 times Nicole's age. So that's next year. So next year, Joanne will be 1 plus her age. So Joanne plus 1. Next year, Joanne will equal, right? 6 times Nicole's age. So 6n. But that's not just n because it's next year. So it's next year for Nicole as well. So n plus 1. In 7 years, Nicole will be 1/3 the age of Joanne. Okay, so in 7 years, so Nicole plus 7 will be 1/3 the age of Joanne. So remember, of means multiply. So 1/3 multiplied Joanne. So 1/3, but it's going to be 7 years later for Joanne as well. So how old is each girl now? Okay, so the first thing I want to do is I really want to get rid of this fraction because fractions are harder to deal with. Whole numbers are easiest for our brains to deal with. So if I multiply every single thing in here by 3, that'll get rid of that fraction. So 3 times n is 3n plus 3 times 7 is 21 equals 3 times 1/3. That just makes it 1. That means I just have j plus 7 over there. Okay, that means I need to take this original equation and I need to solve for either j or n. So I have j plus 1 equals 6n plus 6. And then I'm going to subtract over 1. J equals 6n plus 5. Okay, so now I know what j is. It's 6n plus 5. So I'm going to take this and I'm going to insert it into j. So 3n plus 21 equals, I'm not going to write j, I'm going to write this bit. And I don't need a parenthesis because nothing's being multiplied by j here. So it's 6n plus 5 plus 7. Okay, that looks good. Now I can combine like terms, get all of my variables over to one side, all my numbers over to the other side. And so I'm going to go ahead and subtract 3n over here. That gives me 3n over there. So 6n minus 3n, that's 3n. And then I'm going to gather all my numbers and put them on this side. So I have 21 minus 7, and that's going to be 14. 14 minus 5 is 9. Okay, so I just divide by 3, and I get 3 equals n. That means Nicole is 3 years old. Okay, so now I'm just going to look for my simplest equation. And actually, this is it. This is the simplest one here. No, not that one. Yeah, j equals 6n plus 5. Okay, so that's where I'm going to throw it into. J equals 6 times 3, 6, 3 plus 5. So 18 plus 5, 18 plus 5, 18 plus 2 is 20, plus 3 is 23. So j equals 23. Okay, so that looks pretty good. All right. Okay, same thing. So we're just practicing these types of equations, and we're going to do the same thing with this next equation. 2 years ago, so subtract 2 years, right? 2 years ago into math, subtract 2 years. Tyler's dad was 2 times Tyler's age. So I'm going to write D for dad and T for Tyler. Okay, so dad minus 2, right? 2 years ago, dad was, that means equals, is 2 times Tyler's age. So 2 times, but not Tyler now, Tyler 2 years ago. So T minus 2. Okay, in 23 years, okay, so plus 23 years and plus 23 years for Tyler, Tyler will be 2/3 the age of his dad. Okay, so Tyler plus 23 will be, right, will equal 2/3 the age of his dad. So dad plus 23. Okay, great. So same thing, I don't really like fractions in my equations because it makes it more difficult to solve. So I'm just going to multiply this whole equation by 3 to get rid of that denominator. I could multiply everything by 3 halves, but that would make me have more fractions other places. So I just want to get rid of this one fraction. I'm just focusing on multiplying by the denominator so I can get rid of stuff. I think what I'm going to do is I'm going to solve for D here and then plug it in. So D equals 2t minus 2 times 2 is 4 minus 4. And I'm going to add over 2 to the other side. Okay, that means D equals 2t minus 2. Now, if you're feeling lost, because I did skip a few steps there, you're welcome to just write it out. It's just I don't have a lot of room, so I'm trying to squeeze it in here. But you are more than welcome to write it on a separate piece of paper where you have more room and show more steps if you need to show more steps. Okay, so now we're going to go ahead and multiply this equation by 3 so we can get rid of our fraction. 3 times t is 3t plus 3, 3 times 23. 3 times 3 is 9. 3 times 2 is 6. 69 equals, I get rid of that fraction, so 2. And I'm going to go ahead and distribute that 2 in the parentheses. So 2 times d is 2d plus 2 times 23. 2 times 3 is 6. 2 times 2 is 4, 46. Okay, now I can take this equation and I can stick it in for D. 3t plus 69 equals 2 times 2t minus 2 plus 46. Okay, let's go ahead and take this and write it up here. And I'm always running out of room, so please forgive me for that. 3t plus 69 equals 2 times 2t is 4t minus 2 times 2 is 4 plus 46. Okay, let's get all of our numbers to one side, all of our letters to the other side. We're going to do 46 minus 4 is 42, and then subtract 42 from 69. So 69 minus 42 is 27. So I've got 27 over here. That means I need to subtract 3t over to this side. 4t minus 3t is 1t, which is just t. So Tyler is 27. Now let's figure out how old Dad is. So my simplest equation is this one. So that's what I'm going to stick it into. D equals 2 times 27 minus 2. Okay, so 2 times 27. I'm just going to do the math over here because if not, I'm going to mess it up. We've got 14. 2 times 2 is 4. 4 and 5. Okay, so now we have 54. 54 minus 2 is 52. So Dad is 52 years old. Okay, that looks great. Were you able to figure that out on your own? Okay. If you did not get the right answer, if you tried it on your own and you didn't get the right answer, I really do encourage you before you erase everything, go back through your own work and figure out where you made the mistake. That is so insightful and will really help you learn and remember these concepts. In 5 years, okay, so 5 years from now, remember +5, right? Everyone +5. Carol will be 6 times the age of Heather. Carol in 5 years will be, right, will equal 6 times the age of Heather. So 6 times, but not Heather now, Heather in 5 years. So Heather plus 5. In 2 more years after that, Heather will be 1/5 the age of Carol. In 2 more years after that. So 2 more years after 5 is 7. So +7. Heather, so Heather plus 7 will be 1/5 the age of Carol plus 7. How old are Carol and Heather now? Perfect. So first thing I want to do is get rid of my fraction, right? So I'm going to multiply this equation by the denominator, which is 5. So I get rid of that fraction. So 5h plus 35 equals, it completely gets rid of that fraction because I have a 1 in the numerator. And 1 times c plus 7 is just c plus 7. So c plus 7. Okay, now I'm going to look at this equation. What can I solve for? And I'm really thinking I want to solve for c. So c equals 6 times h is 6h. 6 times 5 is plus 30. And then I'm going to go ahead and subtract over 5. So subtract 5. So c equals 6h. 30 minus 5 is 25. So plus 25. Okay, so that gets stuck in here. So 5h plus 35. Remember, I'm just copying this down until I get to c, in which case I'm going to stick in what c equals. So equals 6h plus 25. And then I'm going to finish writing my equation plus 7. Get all my letters to one side, all my numbers to the other side. So minus 25. Oh, yeah, let's do that. Minus 25 from 35. So minus 25, that'll give me 10. So I've got 10 and then minus 7. 10 minus 7 is 3. So I'm left with 3. And then 5h, I'm going to subtract that over to the other side. 6h minus 5h is 1h or just h. So it looks like Heather is just 3 years old. Okay, let's find the age of Carol. So up here. So I'm going to stick in 3 for Heather. So Carol equals 6 times 3 plus 25. 6 times 3 is 18. 18 plus 25. And that's something I feel like my brain will mess up. So I'm just going to write it down. 8 plus 5 is 13. And then 4, 43. So C equals 43. Okay. On to the back. A boat travels at a rate of 12 miles per hour without any current. The boat went downstream for 2 hours and then turned around and returned to the starting point in 6 hours. Okay, so let's just draw a picture and kind of understand what's going on. So current, and the boat, right, went downstream and it took, right, it's going 12 miles per hour, right? There's water. And when it went downstream, it took 2 hours. And then when it came back the other way, same distance, right? The distances are the same. It took 6 hours. So when they're fighting the current, it takes a little bit longer. That makes sense, right? How far did the boat travel each way? And what is the speed of the current? Okay, so there's going to be the speed of the current and how far did the boat travel? That's going to be distance. So we want to know distance and we want to know the current. Okay, so do you remember the equation for distance? Our distance, rate, time equation. You should have it memorized. Distance equals rate times time. So the rate that the boat is traveling is going to be 12 miles per hour plus the current. Because when we're going with the current helps us a bit. So we're actually going faster than 12 miles per hour. But when we come back, it's going to be the current minus 12. It's going to be 12 miles an hour minus the current. So the current is going to have to be less than 12 miles per hour. I think I'm thinking about that right, because when we come back, we're not actually coming back at 12 miles per hour. We're actually coming back at 12 miles per hour minus whatever the current is, because that slows us down a bit, but we're still able to move there. If the current was stronger than 12 miles per hour, then we would be floating downstream. We wouldn't be able to make it back. So in order for our math to make sense, we need to make sure the current is under 12 miles per hour. Okay, so Ooh. Okay, so our rate is going to be equal to, when we go down, the rate is going to be equal to 12 miles per hour plus the current, right? Because the current's helping us. We're going to go faster than 12 miles per hour. And so that's the rate downstream. The rate upstream is going to be 12 minus the current, because the current is fighting us. So we're actually going to go slower than 12 miles per hour. But the distance does remain the same. So time for the downstream is going to be 2 hours, and time for the upstream is going to be 6 hours, but those distances are going to remain the same. So we can get an equation of 12 plus c times the time, which is 2 hours, equals, and we can set these two equations, these two distance equations, equal to each other because we know the distance is the same. Equal to 12 minus c, that is our rate, times 6 hours. Okay, so we actually here, we have one equation and one unknown, so we can solve it without any problems. So 2 times 12 is 24, plus 2c equals 12 times 6 is 72, right? 72, yeah. 72 minus 6c. So let's get all of our numbers and all of our letters on the same side, on opposite sides, or you know what I mean. So let's go ahead and add 6c over to this side. So 2c plus 6c is 8c equals negative 24. So 72 minus 24. So 12 minus 4 is 8. And then we have 7 minus 1 is 6. 6 minus 2 is 4. We have 48. So 48. So C equals 48 divided by 8. So that's 6. 6 miles per hour is going to be the speed of the current. Okay, so great. So now we've got to figure out the distance. And we can use either equation. You can use the equation going downstream, or you can use the equation going upstream. They will both work out the same because those distances are the same. So I'm just going to plug in distance. I'm going to use the current going downstream. So the distance, we don't know, equals the rate, 12 plus c, times the time, which was 2 hours. Oh, and it's not c. It's not 12 plus c. It's 12 plus 6. Sorry about that. I found c. 12 plus 6. And 12 plus 6 is 18. 18 times 2 is 36. So the distance was 36 miles, because our units are in miles per hour. So it's going to be 36 miles. So great. All right, number 6, a bird flew with the wind for 3 hours. Okay, so this is going to be very similar, but instead of current, we're going to have wind. So let's draw a bird. And I am such a great artist here. Have a little bird here. And the bird is going to fly with the wind for 3 hours. So with the wind for 3 hours and covered a distance of 36 miles. Okay, so these distances are not going to be equal. So I'm going to go the distance with the wind is going to be 36 miles. Then it turned around and flew against the wind. And the wind, I'm going to just draw the wind and it's going this way. Okay, against the wind. Then it turned and flew against the wind, going 2 miles in 1 hour before stopping to rest. So it traveled 2 hours and distance against the wind. It only traveled, whoops, sorry, that got backwards in my brain. Took 1 hour and it went 2 miles before stopping to rest. What was the speed of the bird and the speed of the wind? Okay, great. So our rate is the question mark here. And it's going to be the speed of the bird plus the speed of the wind. Okay, so what we actually want to do here is we're going to have 2 distance equals rate times time equations because we're going to have 2 equations and 2 variables. Okay, so we have the first distance equation is the with the wind. So the distance with the wind is 36 equals rate, which we don't know, but we know it's B plus W, the B with the wind plus the wind with the wind speed, multiplied by the time, which is 3 hours. Okay, and then we have against the wind distance equation, we have 2 equals the bird against the wind, which I'm actually just going to be labeling as B and W because these are going to be the same values. So they actually don't need a subscript, whereas the distance values are different. So they need a subscript. So I think these rates are going to be the same. They're going to be B plus W. Okay, so we have 2 equals B. Instead of plus W, it's minus W, right? Because our speed of the bird is being subtracted by the wind. So the bird is able to travel against the wind, and so our wind speed is going to be less than the bird speed. If the wind speed was more than the bird speed, then the bird would be flying out of the wind and not able to travel against it. And that took 1 hour. So the time is 1. Okay, this looks good. I have 2 equations. I have 2 unknowns, and now I can solve. So, I think I'm going to take this equation and solve for the bird's speed. Okay, so I can just drop out this 1 because I'm a mathematician. Anything times 1 is just going to be that thing, right? So I have 2, and then I'm going to add over W. 2 plus W equals B. So I hope you can look at this equation and really visualize that. Solving it in your head before you write it down is a great way to really visualize math and get your math work done, hopefully a little bit faster. So I have 2 plus W equals B. Okay, perfect. Now I'm going to take this first equation and I'm going to stick this in for B and see what I get. So I have 36 equals, I've got to distribute this 3 first. 3B plus 3W. Now I can plug stuff in. 36 equals 3 times 2 plus W plus 3W. Now I can go 36 equals 3 times 2 is 6 plus 3W plus 3W. Okay, looking good. So I've got 6W over here, and I'm going to subtract 6 on the other side. That gives me 30. And then W, I get 30 divided by 6, or 6 times something is 30, and that something needs to be 5. So the wind speed is going to be 5 miles per hour. So I really like to put in units just because we're doing a real world problem. So we want to make sure that our units match. So I'm actually going to write it up here. Wind speed equals 5 miles per hour. This really tells my teacher or my homeschool teacher that I understand what I'm doing. Okay, now I can take this equation and put it back into my simplest equation so that I can solve for B. Okay, so I have 2 plus 5 equals the bird speed, and that's 7, right? Simple. 7 equals the bird speed. Okay, and then I'm just gonna make a little note. Birds speed equals 7 miles per hour. Completely running out of room, but hopefully if I circle it, then my homeschool teacher will know exactly what I did and what answer I got. Okay, great. A few more to go. A barge can go 21 miles downstream in the same time it goes 9 miles upstream. The rate of the water is 2 miles per hour. What is the rate of the barge? Okay, so same thing. I'm going to draw a barge is a super big ship, and I'm going to draw it like that. This tells me that it's a barge. A barge can go 21 miles downstream. 21 miles downstream. Downstream. You can abbreviate it or write notes however you like. In the same time, so time down equals time up. That just lets me know that the times are the same. In the same time, it goes 9 miles upstream. 9 miles upstream. Okay, the rate of the water is 2 miles per hour. So water is 2. What is the rate of the barge? Okay, super simple, right? So my times are going to be equal. So I'm going to go ahead and manipulate this distance equals rate times time. And I'm going to set the times equal to each other. I really think that's going to work in this case. Okay, so I'm going to go ahead and divide by R on both sides. So I get D divided by R equals T. Okay, so D downstream, the distance downstream is 21 miles. So 21 divided by the rate. So we know the rate of the water is 2. So when I'm going downstream, the water is actually helping me. So we're going to add it to the rate, the barge. So barge plus 2 equals, the distance upstream is 9 divided by the rate upstream. So upstream, remember that the rate of the water is not going to help me. It's going to go against me. I'm going to take the rate of the barge and I'm going to subtract 2. Okay, now I can just cross multiply, right? I have one equation, one unknown. I can find this. So 21 times b minus 2. So 21 times b minus 2 equals, and then 9 times b plus 2. 9 times b plus 2. 21 times b is 21b. Minus 21 times 2 is 42. Equals 9 times b is 9b plus 18, right? 9 times 2 is 18. Get all my letters on one side, get all my numbers on the other side. So I have 21 minus 9. So 21 minus 1 is 20. 9 minus 1 is 8. 20 minus 8 is going to be 12. So I've got 12b on this side. And I'm going to add 42 on this side. 2 plus 8 is 10. Okay. And then carry the 1. And then 4 plus 1 is 5 plus 1 is 6. So 60. So B is equal to 5 miles per hour. So adding those units lets me know that I know B is speed. That's the barge's speed. Okay. So just for fun, it doesn't ask this, so this is extra. How long did it take to go downstream and upstream? We know that it's the same time, but how long did it take? So we can just take one of these equations. So the time upstream is 9 divided by the barge minus 2. So that's 5 minus 2, that's 3. So 9 divided by 3 is t equals 3 hours. So that was extra credit. If you got that and I was your homeschool teacher, I would give you an extra high five or an extra credit. An airplane flew between two cities at the speed of 200 miles per hour. Okay, city 1, city 2, and I've got an airplane thingy going on. So you can decide if that looks like an airplane. An airplane flew between two cities at the speed of 200 miles per hour. So the airplane speed is 200 miles per hour. With the wind behind the plane, the trip took 9 hours. The return trip was against the wind and took 11 hours. Okay, so we have the sorry, just trying to think through my head how I want to do this. I have 200, the speed of the airplane, and it with the wind. So the wind is helping us. So it's only going to take, so that's my distance. Distance equals rate times time. So this is my rate. Sorry, this is my rate. And I'm going to multiply it by the time. And it took 9 hours. And that between two cities. Yeah, we don't know yet. That's the distance. Okay, distance with the wind. Okay, distance against the wind is going to be 200 minus W because the wind is not helping me. It's working against me. And it took 11 hours. What was the distance between the cities and the speed of the wind? Okay, so let's find the speed of the wind first. That means we're going to set this equation equal to this equation because the distance between the cities is always going to be the same, whether I'm going this way or this way. So I have 200 plus W times 9 equals 11 times 200 minus W. 9 times 2 is 18, so that's 1800 plus 9W equals 11 times 2 is 2200 minus 11W. Okay, we're going to go ahead and do letters, numbers. So plus 11 equals 20. And then subtracting 18, 22 subtract 18. 20 subtract 18 is 2. So 22 subtract 18 is 4. So I've got 400. All right, and then cross out the zeros, right? If I divide by 10 by both sides, and then I'm going to go ahead and divide by 2, divide by 2. 40 divided by 2 is 20. So W equals 20. So the wind speed is 20 miles per hour. So make sure you get your units so that your teacher or your homeschool teacher understands that you understand what this 20 is. Is it $20? Is it 20 inches? Is it 20 miles? But no, it's 20 miles per hour. It is a rate. Okay, and then what was the distance between the cities? All I have to do is I take this and I'm going to plug it into my equation up here. So I have 200 plus 20 multiplied by 9 equals my distance. So 200 plus 20 is 220 times 9. And I'm going to work out some long multiplication down here so that I figure this out. 9 times 2 is 18. 9 times 2 is 18. Okay, so 0, 8, 9. Oh, you can't see what I'm writing, but 0891, that's 1980. So 1,980 miles. Include those units so that your teacher knows you're not talking about $1,980, it's miles. Okay. And that is it. That's what we want to know. What was the distance between the cities and the speed of the wind? Distance between the cities and distance between, and the speed of the wind. So great. So that is it for math today. I really enjoy these distance equals rate times time equations. I think they're super fun and they're really not that bad once you think through the process. So I will see you next time. Bye.